Right, it's time to remind ourselves about these 4 types of nuclear radiation here and NZ graphs, both of which we've seen at GCSE. So alpha particles are 2 protons and 2 neutrons, and that's how we write them in a decay equation. Remember, they get stopped by skin or paper, so but they do a lot of damage, very ionizing. Next, we've got the beta particle, which remember is an electron, and they have sort of medium range, medium ionizing abilities. They're stopped by a few millimeters of aluminium. And then that's the positron, which we write like this, same thing. And then the gamma ray is very penetrating, but not very ionizing in comparison to the others. Okay, and here is an NZ diagram. Now, I'm a big fan of NZ diagrams. I think they're very easy to use, very intuitive, and they just show you the number of neutrons in the nucleus on this axis and the number of protons in the nucleus on that axis. So let's say this is my nucleus that I'm starting with, and it's going to undergo alpha decay. So it's going to lose an alpha particle. Now, if you lose an alpha particle, no quarks have changed there. You have just literally lost 2 protons and 2 neutrons. So that means you're going to move to there. So that's what alpha decay looks like on an NZ diagram. Next, let's do beta decay. So once again, in beta decay, you've got one of the down quarks in a neutron turning into an up quark, and so the neutron turns into a proton, and an electron, and once again the antineutrino. So if this nucleus here is going to undergo beta decay, then it's going to lose a neutron and it's going to gain a proton. So it's going to lose a neutron and gain a proton. It's going to end up there. So that's what beta decay looks like. Positron decay is that one. So you're going to lose a proton and gain a neutron. So let's say we were there, going to lose a proton and gain a neutron. Yeah, so it's just the opposite of beta minus decay. And then gamma decay is just that. You don't go anywhere. Don't change the number of protons or neutrons. Okay, so have a go at this question. Okay, so we've got, here's our bismuth nucleus, and it's going to first decay into polonium, and then the polonium is going to decay into lead. And so this first decay here, that is going to be beta decay. We've lost a neutron but gained a proton, so our baryon number doesn't change there. The number of nucleons doesn't change. You didn't need the antineutrino, but we know it's there, so we're going to put it in. And then the next one, we can see that we've lost 2 neutrons and 2 protons, so that means it was alpha decay. And so we have, in fact, lost 4 nucleons. Our nucleon number there goes down by 4. Okay, and then it says, how would we find out which decays were happening? Well, this one is beta decay, this one is alpha decay, so we can use different thicknesses of material and find out what thickness they're going through.